In this video, we'll discuss about rank transform of an array. First, let's understand the question. Given an array of integers ARR, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. Rank is an integer starting from 1. Larger the element, larger the rank. If two elements are equal, their rank must be the same. Rank should be as small as possible. So what they are saying is, let's suppose you are given an array which is 40, 10, 20 and 30. So you need to assign rank to all these elements in such a way that the smaller element gets the smaller rank and the larger element gets the larger rank, and the rank starts from 1. So in this case, the smallest element is 10. So this will get the rank as 1. Now which is the next element greater than 10? That's 20. So this will get the rank as 2. Which is the next element greater than 20? That is 30. So this will get the rank as 3. Then the next element greater than 30 is 40. So this will get the rank as 4. So this is what they are expecting as the output. And in case of equal elements, we have to assign similar rank. So meaning, if my ARR is 100, 100, 100, in this case the smallest number is 100, so this will get the rank as 1, and since all elements are same, all of them will get the rank as 1, and this will be our answer. Now if you see here, if my array elements are sorted, it will be easier for me to identify their ranks, right? So let's see how are we going to approach this. I'll write the test case here. So it was ARR equals to 40, 10, 20, 30, and the indices are 0, 1, 2, 3. So now I'll create a copy of this array and I'll sort this copy. Right? Now why are we not modifying the original array? Because we need the original indexes of all the elements, because once we'll sort them, we'll lose the original indexes. That's why we are not modifying the original array. We are creating a copy and then sorting it. So this sorted copy will contain 10, 20, 30 and 40, and the indexes will be 0, 1, 2, 3. Now I need to identify their ranks. For that purpose, I'll create a hash map. Map int, int mp. So this in the key will store the element, and in the value it will store the rank of that element. Okay. So I'll take a variable rank whose initial value will be 1. And let's suppose I have n, which is storing the size of my array. So arr.size. Now what I'll do, I'll loop from 0 till n and I'll update the rank of that element. So I will do mp of copy of I equals to rank. Right? Now when are we going to update our rank? So whenever my current element is greater than the previous element, in that case I'll increase the rank. So what I'll do is, if I is greater than 0, why greater than 0? Because when I is 0, we are at the first element. We do not have any other element to compare it with. So that's why we'll check for I greater than 0. And we'll check that the copy of I, that is the current element, should be greater than the previous element, that is copy of I minus 1. If it is, then we'll increase the rank by 1. And after that we'll update our map. Okay, so at this point, how our map is going to look like? So since we are looping from 0 to n, initially we'll get 10, right? So I is 0, so 0 is not greater than 0, so it won't go inside this. So we'll do mp of copy of I. So copy of I is copy of 0, and at 0th index we have 10. So mp of 10 equals to rank. Rank is what? 1. So mp of 10 equals to 1. So our map will store 10, 1. Next, I becomes 1. The element is 20. Now here 1 is greater than 0. Yes, it is. 20 is greater than 10. Yes, it is. So we'll increase the rank by 1. So my rank will become 2. So now what I'll do? mp of copy of 1, which is 20. So mp of 20 equals to 2. So this will store 20, 2. Now my I will become 2 and the number will be 30. So 2 greater than 0? Yes, it is. 30 greater than 20? Yes, it is. So we'll increase the rank by 1. So now my rank will become 3. So now what I will do? MP of 30 equals to 3. So this will store 30 comma 3. Now my I will become 3. My element will be 40. So now is 3 greater than 0? Yes it is. Is 40 greater than 30? Yes it is. So I'll increase the rank by 1. So my rank will become 4. So now this will be MP of 40 equals to 4. So this will store 40 comma 4. And that's how my map will look like. Now in my map, I have all the elements in the key and their corresponding ranks as the value. So what simply I'll do is, I'll iterate inside my array from 0 to n, and I'll do ARR of I equals to MP of ARR of I, right? So in this case, initially I is 0. So what it will do? ARR of 0 equals to MP of, what do we have at ARR of 0? 40. So MP of 40. And what is MP of 40? 4. So it will store 4 at this index, right? So we'll write it with some other color, 4. So here it will store 4. Next, I will become 1. So it will do ARR of 1 equals to MP of, what do we have at ARR of 1? 10. So MP of 10. What is MP of 10? 1. So we'll do 1 here. Then our array, the index will become 2. So we'll do ARR of 2 equals to MP of 20. What do we have at 20? 2. So this will store 2 here. Then I will become 3 and it will do ARR of 3 equals to MP of ARR of 3, which is 30. So MP of 30, which is 3. So it will store 3 here. So this will be our answer. Now if you see here, first we created a copy, we sorted it, then we created a map, stored the rank corresponding to the elements, and then updated our ARR. Can we eliminate the need of this, creating a new vector and then sorting it? See, we are using map here. In an ordered map, we already have the keys sorted in ascending order, right? So can we make use of that? If we use an ordered map, then we can eliminate the need of creating a copy array and then sorting it, right? So let's explore that approach as well. So in that case, what I'll do is, I'll create a map which will be of type integer comma vector int, and let's name it MP. So I'll just write the test case here again. So it was 40, 10, 20, 30. I'll give the indexes 0, 1, 2, 3. Now why are we creating int comma vector int? Because this key will store the element and this value will store the index of the element, means all the indexes of that element. So let's suppose if this 10 was coming multiple times in my array, then it would store 10 comma I1, I2, I3 and so on. Like all the indexes of 10 will be stored. So when I have identified the rank of the elements, I want to know at whichever index that element was coming, there I need to update the rank. So that's why we are storing the indexes of the element. So what we'll do, we'll loop inside our array I equals to 0 to n, and we'll do MP of ARR of I dot push back I. So what it will do, it will update our map. So we'll do MP of, firstly I is 0, ARR of 0 is 40. So MP of 40 dot push back what? I is 0. So this will put 40 here, 40 comma 0. Then again it will put for 10, which will be 1, then for 20, 2, and then for 30, 3. Now since this is an ordered map, this will be sorted in ascending order. So this will actually be 10, 20, 30 and 40. So this is how our map will look like. Now what I will do, I'll take a variable rank with its initial value as 1. And now I will map inside my map. So let's suppose I'm getting a pair every time out of my map, and then I'll loop inside the value of this map, meaning the indexes of this element. So I will do index of pair dot second, right? Pair dot second, and I'll simply do ARR of index equals to rank. So for this particular element, whatever were the indexes, assign this rank to that index. Now once this loop is completed, we'll increase the rank by 1. And that's how we'll get our answer. At the end, we'll return ARR. So let's dry run this. So what is happening here? So initially our rank is 1. We are getting the pair 10 and 1, right? And our array is, we'll write it below. Our array is 40, 10, 20, 30. Indexes are 0, 1, 2, 3. So firstly we are getting this pair. Then we'll loop inside this. It is only one element. Index will become 1. So what we'll do? ARR of 1 equals to rank. Rank is what? 1. So ARR of 1 equals to 1. So what is at ARR of 1? 10. So here it will store 1. Now since there was only one element, this loop got completed. We'll increase the rank by 1. So rank will become 2 now. Now the next pair that we get is 20 and 2. Now it will loop inside this. Index will become 2. So it will do ARR of 2 equals to rank. Rank is 2. So ARR of 2 equals to 2. Right? Now this loop got completed. The rank will be increased by 1. Now the rank will become 3. Now the next pair that we'll get is 30 and 3. This is only 1. We'll loop inside it. Index will be 3. So now this will store ARR of 3 equals to 3. So this will become 3 here. Now this loop got completed. We'll increase the rank by 1. Rank will become 4 now. Now the next pair that we'll get is 40 and 0. Now it will loop inside this. The index will be 0. So it will do ARR of 0 equals to 4. So it will store 4 here. Now this loop got completed. We'll increase the rank by 1 again. But now when it will come here, we have already traversed the entire map. So this will return. So this will be our answer. So here we have eliminated the need of creating a copy and then sorting it. So now let's code this solution. So first we'll create a vector whose key will be of type integer and value will be of type vector int. Then we'll loop inside our array ARR.size, and then we'll push the indexes in our map. So MP of ARR of I dot pushback I. Then we'll take a variable rank whose initial value will be 1, and then we'll iterate inside our map. So we'll get a pair. So this is MP, and then we'll loop inside the indexes. So int index in pair dot second. Okay. Then we'll simply update all the indexes with this rank. And once this loop is completed, we'll update the rank by 1. And at the end, we'll return the array. Let's run it. So in this case, if you see, first we are looping from 0 till end of the array, which is n, and here we are pushing into the map. And the complexity of inserting into the map is log n, and here we are traversing till n. So the complexity of this code will be n log n. Okay. So all our test cases are accepted. Now we'll submit this. So it's accepted. Thank you so much for watching.